sir. No, I'm going to introduce. Uh, Thank you, sir.
Mhm.
Now I am going to start the session. Good afternoon, everyone. We are privileged to introduce Professor Dr. Niranjan Swarup, sir, Director General of Indian Society for Trenchless Technology, IND-STT. He is BTech in Civil Engineering in 1987. He has been involved in various infrastructure development projects. The assignments handled by him have ranged from design, estimation, project planning, and execution. In addition to being a trenchless technologist, Professor Niranjan Swarup is also a formally trained arbitrator from Singapore International Arbitration Center, lead quality assessor under ICQ project of European Council. He is currently the board member of various professional bodies like Engineering Council of India (ECI), International Council of Consultants (ICC), and the Council for Application of Actuarial Science in Risk Management in Construction and Allied Industries. He also represents India on the board of several international organizations like Asian Forum, Asian Concrete Construction Institute, International Council of Consultants. He is nominated member of several consultative committee like Bureau of Indian Standard (BIS). He is the member secretary of several task force and working groups for different bodies. The prominent of them are the Jawaharlal Nehru National Urban Renewal Mission and National Council for Vocational Training. Professor Niranjan Swarup sir is one of the prominent trenchless technologists recognized internationally and invited to speak at the most of the important international trenchless event world over. He has to his credit several trenchless publications. He is the editor of No Dig India Journal and regularly contributes articles in the international trade and technical journals. He has contributed substantially for the formation of code of practices for installation natural gas pipeline of BIS. In addition, he has developed code of practice for several trenchless techniques like directional drilling, horizontal earth boring, and pipe jacking. He has edited and authored several textbooks and training manuals related to construction and trenchless technology. He has been responsible for initiating several trenchless courses titled Subsurface Utility Manager, Trenchless Pipeline Manager, and Post Diploma courses in trenchless technology. Additionally, he is now initiating several courses on SSEM, pipe bursting, and other trenchless subjects. He is also involved in establishing trenchless technology research and education centers across India. The first of them is now being initiated at Vidisa, Madhya Pradesh, titled National Habitat Center on Subsurface on and Trenchless Technology under partial grant funding of AICTE. Recognizing his contribution to the trenchless construction industry, Singhania University accorded him the title of Doctor of Philosophy in the year of 2012. Welcome to you, sir. Now over to you, sir. Please take the session, sir. Thank you.
Thank you, Pratibha, and welcome everybody. Today we are talking about constructing below the ground surface, subsurface construction. And my intent is to convince all of you to create engineers, create professionals which are badly needed for the nation. And I hope you'll accept my this proposition. We'll be going through this presentation where we'll be talking about what is subsurface construction, what is trenchless technology, and what are the needs, what are the specific skill sets that we need to create within our students, how do we go about it, and can we go in for some kind of project work, all those things. The primary aim is that you are given a clear understanding of trenchless technology operations. You are also encouraged to ask questions. You can raise the questions as they'll be included in the booklet or in the assigned outcome of these PARAKH programs for AICTE, so that students also are able to benefit from them and all the stakeholders benefit. So let me upload my presentation first. A copy of that shall be shared with you by Pratibha post conclusion of this presentation. So let me just open that. I don't know what is this.
Sir, could you please left the meeting and rejoin the meeting, sir?
I should leave and rejoin it?
Yes, sir.
Okay. Starting with Pratibha, can you run the presentation from your end and I can speak here?
Yes, sir.
So
Yes,
please
sir.
load the presentation from your side. I don't know why it is not loading today.
Okay, sir.
You start it.
Okay, sir. Okay, sir.
I've made this presentation and shared the copy with Pratibha, so Pratibha can run from her end, and I'll be talking on the presentation. Now the presentation is titled Subsurface Construction. Pratibha?
Yes, sir. Yes, sir. I'm
Yeah.
opening, sir. Yes.
Okay. I'm sorry for this hiccup. So while Pratibha is uploading it, let me just start talking about it. Yeah, I think she got it. No. हाँ भाई हुआ प्रतिभा. All right. Till she starts. This is basically subsurface construction what we are talking, and this is faculty development program under ASLAP or PARAKH. This presentation is being done by me. My name is Dr. Niranjan Swarup. I'm the Director General of Indian Society for Trenchless Technology. As Pratibha introduced me, I promote trenchless technology and I assist the construction fraternity, the engineering fraternity in implementing the subsurface construction projects where they require to construct structures below the ground without excavating continuous trenches. Now, the bottom line is underground space is the future of urban settlements. We need appropriate vision to preserve it for our future generations. The underground space, what we have here, is something which has been given to us from by our ancestors and has to be handed over to our next generations. We need to preserve it as best as practicable and as best as possible and provide it to our coming generations. As engineers, this would be our business to do this particular or to work out in this direction. Pratibha, are we done?
Yes, sir, I am sharing, sir, but there is facing an issue,
You're also
sir.
facing a
I'm,
difficulty?
yes, sir, I'm trying, sir. Sir,
Mm-hmm.
yeah, sir, could you please continue? I'm trying, sir.
अच्छा ठीक है चलिए
Okay, okay, sir.
just a sec. I've structured this presentation into 6 sections: background, subsurface space, subsurface constructions, trenchless technology, academic initiative needs, and then finally concluding remarks. So to talk about first the background, trenchless technology is the family of subsurface construction techniques that help in remotely constructing, maintaining, or replacing subsurface utilities buried below the ground surface without excavating continuous trenches. In national context, trenchless techniques have an extensively important role both during construction as well as later during the operations, maintenance, and replacement at the end of economic life. As the urban area managers, it becomes imperative for the engineers to have sufficient internal capability for constructions, operations, maintenance, and replacement of buried utilities, both conventionally as well as through trenchless methods. The boys and the girls whom you are teaching need to have these capabilities. And please do not misconstrue that only the civil engineers are going to construct. These particular processes require almost each type of engineering, all branches of engineering, because this is an applied field. And that is what we have been trying, or we have been communicating with the people, so that people can uh, basically develop, maintain, manage, and at the end of its economic life, terminate the utilities as best as practicable. Through this capacity, the nation would be able to get subsurface utilities developed and managed efficiently and effectively. And naturally, if we do that, we would be creating assets, we would be containing the wastage of the subsurface space and optimizing the expenses. That is what is needed from our engineers. Prerequisite to achieve this capacity is to have proper vision for the application of trenchless. Pratibha, you have not been able to load it?
No, sir. I am rejoining from the laptop, sir.
Mm-hmm.
So I am trying, sir.
I'm extremely sorry for this. I got it here. All right. Which one should I mute? Okay. Am I audible, Pratibha?
Yes, sir. Yes, sir. You're audible, sir. Screen is visible, sir.
Screen is visible? Okay. I'm
Yes.
extremely sorry for this confusion. Just my laptop decided not to display it. So this is subsurface construction. Underground space, as I talked, is the future of urban settlements, and we need appropriate vision to preserve it for our future generations. The presentation is structured into 6 parts: background, subsurface space, subsurface constructions, trenchless technology, academic initiative needs, and finally concluding remarks. My intent is to encourage all of you, all the faculty members, to think about the basic needs, create your questions, and let those questions be provided so that those could be answered and we could work out some more useful inputs for our students.
Sir,
Hmm.
now, sir, PPT is present.
Did you get your present?
Yes, sir.
Okay, so this is better because I'm trying to run it from my mobile, and that's the reason it's every time going off. So,
Yes, sir. Now it's comfortable for you, sir.
okay, yes. So please move on the next slide. Next slide. Next slide. Next slide. Next. Okay. For the capacity creation, we need academic institutions to see ahead and include systems to cultivate students capable of rendering services for such engineering requirements. In this talk, we shall be looking at the different aspects of subsurface construction and such vision attributes and modes to create national capabilities and put them to use in nation building. Please, this USB device is not, I think you should put it on a presentation mode. At least then that way it will be visible easily. Pratibha? Okay, go on the next slide, please.
Yes, sir.
So now, let's start with subsurface space. Please move on. Next slide. Back. Yeah, next slide. Yes. Please move on. Next one. Now, conventional construction techniques means surface disruption. You will excavate the ground and create a structure, damage to the adjacent structures, cost and duration of work related to above ground structures and constructions, increasing mechanization due to deeper installations, and enhanced challenges in cut and cover methods, making bore tunneling or trenchless methods better options. So, this is what the conventional construction problems are. Please go on the next one. So when I'm going with cut and cover or open cut, the underground space in the public right of way is heavily used. Traffic congestion is growing. Street pavements are damaged. Cost of surface restoration is going up like anything. And direct and indirect business losses are occurring when we are cutting and covering our roads or our public areas where the structures are being laid below the ground. We are talking about utilities like pipelines, cables, oil and gas, infrastructure, all those things which are being put below the ground surface. Please go on the next slide. Pratibha. Now, another situation which most of you might have seen, the collapses of road. Have you seen these things happening in your area where the road has collapsed because the subsurface pipelines have collapsed? Go on the next one, please. Pratibha, next. Have you seen these happening where the vehicles, the buses have gone inside the road? Next one, please. A common problem in many of the older cities that the drainage systems are completely clogged, and because of that clogging, the fluid is coming onto the streets, and we call that combined sewer overflows, which makes living almost like a hell. Please go on the next one. You must press one more down. You must have seen or must be aware that we are putting gas pipes right, left, and center everywhere. Do you expect this kind of accident occurring in your areas? I believe if you don't expect, you are not seeing the future. And if you expect, that means we have to prepare our boys and girls so that they can avoid these accidents. You have a gas pipeline and somebody comes and simply damages it. And somebody just lights a matchbox. And this is what the picture you can see. Next one, please. When you have a pipeline which is leaking, what would happen is that that pipeline will permit the external fluid to flow in, which is on the first figure you are seeing. This fluid along with it will bring soil in the pipe, and the soil void will be created. The net result would be these three pictures, and believe you me, this picture is from Gurgaon, the central picture. The right picture is again from another Indian city. The first picture is from America. So the left bottom picture. So you can understand the effect of system failure, and it's happening all around the world. And we need to create professionals who can serve India, who can serve the world infrastructure industry. Please go on the next slide, Pratibha. So the question is, please decide, do we want our subsurface infrastructure built to serve us, or do we continue serving them rather by creating or repairing those? The the appurtenant infrastructure consistently, that is the pipelines, the manholes, everything, if we just go on repairing them, it's our loss. So what do? Please go on the next slide. Pratibha. For creating new subsurface infrastructure, we need construction methodologies that reduce open cuts and surface damages while building robust structures. For rehabilitating or repairing the subsurface infrastructure, we need construction methodologies that help in using old subsurface alignment, reducing open cuts while retaining or enhancing the infrastructure quality. Both of them require smallest footprint. Money wise, I am sure you must have heard this from some of our presenters earlier. Our Director General also indicates that we are building close to about 1 lakh crore worth of infrastructure each year. Nation. For the last 25 years, we have been investing this kind of money. Imagine the kind of new construction and maintenance works are being created, and those have to be served by your students. Take a note of that and consider how can you create your students so that they can be an asset to the nation, number one, and the nation is able to get the infrastructure in place. The boys and girls are employable, they get employment as best as practicable. Believe you me, this provides the students or the engineers a pretty good earning opportunity. Please go on the next one. Pratibha? Pratibha,
Yes, sir.
next slide.
Yes, sir. I'm changing, sir. Yes, sir.
So this concludes the second section. Then we come to the subsurface constructions, where I will try to introduce you to the primary concept of subsurface construction as we handle in trenchless or rather in infrastructure industry. Can we move on to the next slide, please? Pratibha? Subsurface works are executed in a non-homogeneous media full of challenges. Possibilities of failure and accidental damages to existing subsurface structures are very close reality if the trenchless application is erroneous. Errors possibly could be erroneous subsurface information, unsuitable technique, unmatched capacity equipment, poorly skilled operations, or poor quality of material or consumables. For a successful project, one needs to remove such errors. And that is what is the business of an engineer. Please go on the next slide, Pratibha. Click down arrow. The utility life cycle, the cradle to grave movement is of 5 phases. Please click the down arrow, Pratibha. It starts with planning and design. Then the construction is done. Then inspection and maintenance are conducted. Then one more down, rehabilitation and renewal is done, and finally replacement or removal. When I'm planning and designing, what I'm talking is about planning the route, conducting the site investigation, visualizing of site model, design for construction, and design for life cycle. This is what are the activities that go in planning and design. Then comes construction, where I'm doing the construction process, update site model, avoid damages, and create construction records so that in future people can refer to those records and know if the pipeline or the structure was constructed properly, and if there are any possible areas of concern that would also be recorded. Then comes inspection and maintenance, which basically means, first of all, I manage the data which I have generated in my construction phase. I allow or install low cost sensors, do smart materials, install smart materials, and get the performance feedback that what kind of loading is coming onto my one structure and what kind of behavior that structure is the behavior of that structure. For an example, if you're building a buried pipeline, that pipeline can never be built for 100% evacuation of all the fluid immediate evacuation. It has to have some kind of timelines of flooding, and that timeline basically defines that in a particular period of time, which could be 1 year, which could be 6 months or whatever, how many times you permit your network to flood, and that itself will help you to maintain, evaluate the load on your structure and design where you're going. Then comes rehabilitation and renewal. Once your structure is in operation, it would start deteriorating. So you need to predict the deterioration, manage the asset, and to do that, you have to select rehabilitation methods, and then update your records. Because once you have created a structure and you have rectified something, the next stage would be to update the record. And finally, when we're talking about replacement or removal, is basically asset management. Believe you me, even cities like in Delhi, we have items where we have to search the manholes. Although the manhole is supposed to be known structure because its cover is seen, but still it is basically buried below the roads and we have to search them. So it's basically finding the utility, design for the replacement, and finally update the record. So this is what is the complete utility life cycle, and this is what is needed when we are talking about buried infrastructure. Pratibha, please go on the next slide. Now, what would be the engineering process steps? defining the requirement, generation of alternate solutions, evaluation of alternatives and selection of most suitable solution, detailed design, design promotion, construction and testing, performance evaluation, and conclusion reporting. This would be a process which can be in place for open cut construction as well as for trenchless, or for that matter, any infrastructure or normal construction project. So this process or this engineering is something which we need to inculcate in our engineers. Please go on the next slide, Pratibha. Now, when I'm talking about subsurface construction and trenchless technology applications are remotely operated smart construction processes that are extremely useful for creating, maintaining, and managing subsurface utilities without continuous excavations. Through this feature, surface and subsurface infrastructure destruction in urban areas can be avoided during construction. This also helps you to cross major geological barriers, like when you're laying any pipeline and there's a river, you can comfortably cross the river without disturbing the river or without stoppage of your work. In addition, positioning processes, because these are remotely controlled, so obviously it would generate information of the activities of your equipment or your smart materials, that this is what is happening at this location, XYZ coordinates, and those XYZ coordinates would be available to you. And you can, in turn, create a complete database of the system. And this basically means, if you're talking about a smart city, the smart city will have all the data that where are their utilities buried, what are the specific locations from where XYZ coordinates can be evaluated. The systems of these techniques help in creating correct as-built database of buried utilities, providing valuable input for future maintenance of subsurface utilities. Please go on the next one. Pratibha. Utilities like water supply, drainage, power and telecom lines, petrochemical and gas transmission and distribution networks are commonly buried below the surface. Historically, these have been laid by conventional open cut processes. With enhanced density of subsurface network, trenchless techniques are becoming the preferred construction processes, and more urban settlements are preferring to go in for trenchless technology. Works, however, are becoming difficult with the passage of time and growth of subsurface utility densities. Just for your information, the length of the buried pipeline below the Delhi about 20 years back was close to about 9,000 kilometers. Now it is more than 20,000 kilometers of pipeline buried below the ground in the city of Delhi. So you can imagine the amount of pipeline which is buried there, and how are you going to create, maintain, manage. Trenchless helps there. But then if the trenchless project fails, the failure are culmination of several issues, and the need is to address those adequately. To begin with, we need to look at the basic trenchless construction process that I'll be talking after this. Please go on the next slide. Pratibha. So let us define what is trenchless technology. Please go on the next slide. Trenchless technology is the set of construction methods or methodologies for creating or installation, rehabilitation, and repair of utilities, pipelines, and small tunnels, linked by their lack of need for digging a continuous trench for the installation of new structures or their repair. Please click the down button. So you have generally micro tunneling, directional drilling, rehabilitation, replacement, all those things coming into trenchless technology. There are primarily 4 sections of trenchless technology. Please go on the next slide, Pratibha. There are 4 sections of trenchless technology: creating a new asset, rehabilitating a new asset, rehabilitating a functional asset, replacing a functional asset which has gone bad, seeing through the ground, because we are talking about pipeline, we are talking about remote construction, and I'm not going to excavate everywhere. So that basically means I need to see through the ground. So these are the 4 different sections by which trenchless technology processes are conducted. Please go on the next slide. Now let us just define what I mean by new installation. Under remote controlled operations, subsurface passage can be developed by either shifting the soil sideways, cutting the soil mechanically and removing it axially, or fluid assisted soil cutting, where I point a jet, the jet dissolves the soil and the soil flows back, and actually the cavity is created. All new installation Trenchle techniques use these whole creation mechanism individually or in combination, and that is what basically helps in creating assets, buried assets, without excavating continuous trenches. Then comes the rehabilitation. Pratibha, go on the next slide. Under remote control operations, faulty and leaking liners of subsurface passages can be rectified by plugging the leaks wherever they have happened, or inserting a leak-proof membrane if the pipe structure is capable to carry the load which is being applied from the ground surface. May that be road, may that be bridge or whatever. And then, in case if that also fails, then inserting load-bearing liner to carry the loads as well. So rehabilitation trenches techniques use these three liner rectification mechanisms individually or in combination. Basically, when I create a cavity, that cavity requires a liner, and that liner is generally a pipe, generally concrete sections, steel sections, whatever, and that has to be rectified, and that is what you're doing in rehabilitation. After rehabilitation, to a certain extent, there are times when the rehabilitation process itself will never be helpful. Then what? Then you basically replace the existing pipe or existing surface, the liner of the cavity. Pratibha, please go on the next slide. Under remote control operations, the liner of subsurface passage can be replaced by either bursting the corroded pipeline from inside, like you send some tool which basically bursts it. You can cut it, run through a knife, and the knife opens the sheet and the pipe is removed out, or you implode it. You send certain equipment which basically crushes, breaks the existing pipe, and everything falls within the cutting equipment, and then it is taken off. These are the three primary ways by which you replace your buried pipelines without excavating continuous trenches. There can be a question that why should I not just create another pipe? Here comes my first statement, which I gave you in the beginning, that I need to transfer the complete subsurface asset, subsurface space to my coming generations as best as I had received, or even better if possible. And that is what replacement and rehabilitation helps me to achieve. Please go on the next slide. Then comes seeing through the ground, or looking in the ground, which is subsurface survey. Under remote control operations, subsurface information is gathered by either subsurface utility engineering processes, geophysical investigation processes, or pipeline condition assessment methods. What you require is knowledge or information about buried utilities which can come afoul your pipeline alignment. So that is basically known from subsurface utility engineering processes. The second is that you require to know what is actually below the ground. Though it is a flat surface, it would never be an isotropic ground, and you need to know what is the composition of your strata of the battery limit of your project. So that is what you get from geophysical investigation processes, because geophysical methods will let you know what is the structure of the soil strata. And then comes when you are going to do the rehabilitation of any pipeline or structure, you need to know what is happening inside it. So there are methods by which you can assess the condition. So these three systems, individually or in combination, are applied to find out what is buried below the ground. And that is what helps you to execute three types of project: new installation, rehabilitation, or replacement. Pratibha, please go on the next slide. Now, let's talk about the essentialities of trenchless projects. You are working in a very, very uh, confined area, and you define that your structure is not going to deviate from that particular location. That means you're talking about minimum vertical, horizontal, and vertical clearances. The road setbacks, existing surface features, and existing underground utilities are another essentialities for subsurface project, because you are, let's say you are drilling a hole in the ground and there is an existing pipeline. This drill machine can go and damage that pipeline, and that would basically mean that this structure will fail, and in turn this will also fail this particular operation. So all those things impact your trenchless project. The product pipe and associated tooling diameter requirements, alignment geometry, so the ground profile, because if you are doing a very, very long length, or there is a contouring, what would happen is if you are going horizontally, there is chances that you may come up. So basically what you require is the alignment geometry of the ground profile so that you can install your pipes. Trenchless equipment requirements for geotechnical conditions. If you have specific soil condition, like you are drilling or you're creating a pipeline in a close to a river, say for an example, the river plains near Ganges, or maybe if we talk about southern India, the plateau what we have there. In that plateau, like in Bangalore, if you want to create a cavity, you will be encountering too many locations with hard rock, and that would basically define a specific type of trenchless equipment. Otherwise, you can't execute the project. The equipment and material handling requirements. Let's say you are working in an area where you have bridges, you have the overhead cables or overhead structures, your equipment movement is not possible. All those things will define what are the methods by which you work on the trenchless project. Material strength, capabilities, and joining methods. All those things define what kind of project you can do. Take for an example, you're talking about a pipeline which has to drain everything through gravity flow. It has to be laid in a specific alignment and specific grade. If that alignment is not achieved, the flow will fail. Say for an example, you have a flat line and you lay a pipe like this. Entry and exit are the same level, but other things are at a lower locations or lower levels. Believe you me, this particular section will get flooded very soon, and this pipeline will fail practically within a less time. Whatever design life, what your engineer or your student would be allowing it, will be lost. So all those things define what is required for a trenchless project. Please. Oh, I'm sorry, I just clicked deny entry. Pratibha, please go on the next slide. And now, there are the steps in subsurface construction trenchless. First of all, you select what you want to do. Do you want to go for open cut or do you want to go for trenchless? So the mode selection is the step one. Then comes project impediment identification. As I indicated, you have rocks, you have different kind of soil. So what are the impediments which would be the governing your whole process? Then technology identification and selection would be the next important thing. As I indicated, if you're talking about a gravity flow pipeline, and if you're talking about a pressure pipeline, the best thing would be for pressure pipeline, you don't require that much precision of alignment, because in this case, the flow will be occurring because of the pressure what you are applying through a pump or through any mechanical device. So you can utilize some equipment which has a lesser grade control. But if you require a exact grade control, you require an equipment which can be very precise in millimeters or so. Then comes, once you have defined that, you will be identifying the working methodology, how you are going to execute a project. For an example, I'll give you uh, uh, a project description of Kohima. Kohima is a city which is situated on the side of one mountain range, the water supply over there is not very, what you call, not voluminous. So what is happening is there is a mountain which is about 800 meter above Kohima, and 400 meter down on the other side, there is a river flowing. The idea was to drill a hole and bring that water to Kohima river, Kohima city. Now, there was a 400-meter rise and then 800-meter fall. All this had to be designed and worked out. There were too many challenges, and we had to define how are we going to bring those two holes, because the diameter of pipe needed was about 600 mm, but the people who were not very clear about the engineering went in to suggest that they would create a tunnel which is about 2.6-meter diameter. And then the question came to us, and we came with a proper methodology. How do we do it? By using some specific equipment by which the line can be cleared. And that is what would be the working methodology. And based on that, we selected specific equipment, because you have to mobilize the equipment above the mountain and take it to the other side and create from that. So there is a equipment complement finalization. Based on that equipment complement, and that equipment means what we suggested was to provide two drills, one drill at the other end of the mountain and one drill from this end of the mountain, and both the drills were supposed to be drilling hole and meeting in the middle. So that way we would create a cavity. So you require a specific type of equipment which can be transported above the mountain. You require another type of equipment which can be having this kind of drilling process where it can go up. So all those things were identified, and based on that, equipment selection and related complements, that what all is needed. Because let's say you are drilling a hole. How do you drill a hole from a machine? You'll have a drill rod which will be going inside the ground. When it goes inside the ground, you'll attach another drill rod that will also go in the ground, then you'll attach another drill rod, you'll go behind it, so on and so forth. So there are set of drill rods which go in when you're talking about drilling. If it is a micro tunneling process, what you have is a shield which is moving ahead because of your thrust or your push. That micro tunneling machine will move ahead, and you'll have sections coming behind it, the pipe sections. Now, the pipe sections will be thrusted from the rear, and the machine, because of that thrust, will move ahead. There is a limit by which you can actually apply your force on these pipes. Generally, engineering practice is about 300 meters. That less than, up to 300 meter you can thrust or you can jack the pipe. So what is done is that you can put in a intermediate jacking station or intermediate thrusting station, which basically transmits the load. Just after each 300 meters, you have a machine which is taking it ahead, then a machine which is taking it ahead. All those work together, and those have to be selected, and related complements have to be decided. Pratibha, please go on the next slide. Then comes the material what you are going to install. You select and design the installed materials like pipes or elements, how you are going to have the bends in a structure, how you are going to have the changes of alignment or all those things. All those have to be selected and designed. Then comes consumables. Let's say you are drilling. For drilling, you require some kind of media which can be bringing out the excavated material from the cavity. Now that is called drilling fluid. If you are doing micro tunneling, you require the surface of your tunnel to be lubricated. So you require again a similar fluid, which is lubricating fluid. All those materials have to be designed, because based on the soil condition, you'll have to have a specific type of drilling material or other consumables which have to be used to create those cavities. So that is the next stage or next step. Then comes checking whatever you have designed. So you go for site investigations, recalibrate whatever you have decided, that is the working methodology, design values to address the actual impediments. Then procure the materials, consumables, and services, execute the project and complete it. And finally, report the outcome, that is as-built drawings, execution issues, installation details, all those are recorded. These things, or rather this is a sequential process by which you are executing your trenchless project. your engineers, your students could be very good professionals if they are having the understanding of this complete process, and then they select or they learn in a specific field, new installation field, rehabilitation field, replacement field, whatever the branches they want to go. So, seeing to the ground field. So you require knowledge about ground penetrating radar, pipe and cable locators, all those things do come in. So everything is something which comes and hinges on your teaching. And how do you teach them? The equipment parameters may or may not be available with you, but then we have to source them. We have to locate that where are we going to find such kind of complements by which I can teach. We can help it, or we can do it by going to the projects which are occurring close to our colleges, close to our institutions, and expose our students to those things. Believe you me, most of the nations use this methodology because educational institutions cannot afford these expensive equipment. These expensive equipment are basically available in the construction sites, and there you can communicate and get your learners acquire this knowledge. Again, as you are engineers, you'll be in a position to do several design aspects. That how do you design a pipe, a buried pipe or a regular pipe design? How do you design the buried structures? All those things you already have that knowledge base. You can apply that so that certain kind of assignments are also received, and the institution also gains by your activities. Pratibha, go on the next slide, please. Now, if I want to be successful, my aim is to avoid failure. And if I want to avoid failure, I need to understand what are the causes of my failure. The causes of Trenchle project failure include starts from selection of incorrect techniques. I choose a bad technique and I choose a technique which is not suitable for my requirements. I'm in for a failure. Inadequate site or soil investigation. I do not conduct the site investigation. Simply decide that I want to do the job. If the soil does not meet my the soil requirements, make my method selected incompatible. It will be failure. Inaccurate subsurface interpretation. When I'm using ground penetrating radar, I'm using pipe and cable locator. There are specific methods, specific geophysical or geophysical methods by which I am making certain assumptions. Take for an example, if you are having a large area, you are having one borehole here, one borehole here. You find a level of rock in this borehole at a specific depth. Here also you find it at the specific depth. So you will be presuming that the rock is moving in this direction. But then there can be a fold, there can be a rise. So how you basically select the evaluation locations, number one, and then how do you interpret the information what you're getting? If your interpretation is wrong, you're going to fail. Unforeseen ground conditions. As I said, you have a rise or you have a dip. In either of the cases, and your borehole was here and here, you did not know. So that is a possibility. And there are basically logical methods by which you can really identify that even without boreholes, you can know that what is the ground profile. There are methods, geophysical methods like seismic refraction and reflection. Those basically are sending waves which are hitting the strata and getting reflected. And those reflection times are measured, and by which you can find out what is the depth or elevations of different strata. So unforeseen ground conditions can cause a failure, but all these can be avoided. Then comes damaging the existing utilities. You did not care to know what is the subsurface utility information, SUE, and then you went in and damaged the existing pipe. I have handled a major project in Delhi in which in 1 month there were 10 major pipe collapses. And why they happened? On the same road there was a directional drill which was drilled through the pipeline. The pipeline was punctured, another puncture, another puncture, another puncture. All this in a stretch of about 6-7 kilometers, and that was basically the during in the period of Commonwealth Games in 2010. There was a huge monsoon, and because of that monsoon, it was basically the road was collapsing like anything. The road collapsed at one location. Poof, it was rectified. Next collapse, next collapse, next collapse. In 1 month, 10 collapses. So all those things because of damage, people damaging the existing pipelines, usage of under capacity equipment or equipment breakdown. So these are some of the failure causes. Some more are. Please go on the next slide, Pratibha. Inadequate temporary works. When you're doing a project work and your activities are inadequate, the failure can be there. Installation of inappropriate or weak materials, failure to adhere to work or material specifications, and inappropriate or bad workmanship. So if I'm able to avoid all this, my project is going to be successful. And how do I do it? Because through proper understanding, through proper training, again, I come back to you that this is something which you have to be incorporating in your students. Please go on the next slide. Now, if I am talking about anatomy of the failure in trenchless, is basically what thing should I call a failure? The failure is to complete the installation. Failure is to fail in the job site safety matters. Failure is to damage environmental, natural, or other above ground resources. Failure in surface collapse and heaves. I may be drilling and the soil may lift. And this is a very, very major risk when you're talking about drilling below the railway tracks. You have a railway track and you drill below that, or you pushed your machine below that. The thrust could lift your track. And if your railway track gets lifted up, believe you me, there's going to be a dangerous situation for the trains traveling on the track. It could lead to accidents, deaths, whatever. So that is something. Then comes hydrofracture or inadvertent drilling fluid or fluent returns. I'm aware, or I have been advising projects in which the people which was using bentonite slurry being pumped in, and the return was only water. All the bentonite was being lost. Then damaging other utilities, as we mentioned. Please go on the next slide. Now, if I'm talking about hole creation failure or a bore failure, what it means? It means that I'm unable to get my soil out. Why do I fail to get my soil out? If my circulation fails, that is, I'm pumping something and simply going out. There are obstructions. Something came in front of my machine and the machine is not able to move. There was a major project in Dharavi in Mumbai where a major tunnel was to be excavated, and that tunnel was stopped because of black basalt rock, which had I think 300 megapascal crushing strength. The machine could not move ahead because there was no jacking possible. So obstructions. Hydrolock means you are pumping in and the pressure is basically preventing any fluid to come out. Line and grade failure. You are creating a gravity flow and your line goes like this. Borehole and cavity collapse. I've been from a port. I've been taken as a amicus curiae for a project in western side of India, in which there was a hole to be created. There was a pipeline for gas supply was to be installed, and it had to cross a river. That river crossing literally failed because the moment the machine drilled through the hole, all the river shingles this simply collapsed and the pipeline was stuck. So the borehole or cavity collapse is there. There could be pipe collapse. You're pushing in a pipe, you're pulling in a pipe, and that the pipe is unable to withstand the pressure exerted. Then comes drill pipe or downhole tooling failure. Your toolings or equipment, they are unable to handle it. All these things have to be inculcated in my boys and girls, those who are going to work in these projects. If my boy is confident to avoid these, I have a successful project. Please go on the next slide. The technology issues are basically more remote operation, less direct observation on ground conditions, life cycle approach to design and management of underground structures, great use to see ahead technologies. So all these issues are something where my boys and girls require friend, guide, and mentor. And who is that? That is you. If you are able to teach your boys to undertake or handle these kind of pressures or these kind of projects, nothing like it. Please go on the next slide. Now, what are the needs for a trenchless project? The critical inputs, the trenchless attributes that we'll be talking in the next slide. There are required attributes of executing agencies. How can you work on the project? The technology selection, as I indicated, execution plans, how do you execute it? Third party inspections. Then comes challenges in new installation, liners or pipe bursting. So all those things are critical inputs when I'm talking about trenchless project. And my intent of highlighting all these is that I am proposing that let's work together. Let's go to the urban infrastructure creation, or maintenance or organizations around you, like urban local bodies close to your college. Let us talk to them that look here, you are creating this network and you require the engineering support. We are engineering college. We can assist you because we have the facilities, we have the engineering students, we have faculty, we have the design methodologies or equipment that could help us. So that is what is the basic idea of putting all these things or telling all these things to you. Yes, uh, this will not take you much further. You have to cultivate many things, and we'll be talking about that in the later section. Please go on the next slide, Pratibha. When I said attributes are trenchless, it means it's a specialized nature. Everybody can't do it. It has to be special knowledge which has to be cultivated. The technique selection, operator skills, suitable equipment, installed materials, technique related limitations, proper subsurface data requirements, impact of surrounding structures. All those are the attributes of trenchless which you have to understand and which your student has to understand. And this has to be passed on to him. Please go on the next one. When I'm talking about executing agency, the required attributes of that agency or those that group of people has to be people or company has to be that it has to have the knowledge and experience to execute such projects, appropriate equipment capable to execute such projects, adequately trained and certified operators, adequate capabilities for subsurface investigation or an access to the same. So if these are available, the project can be successful. And as uh, an advisor, as an engineer, you can check it out that yes, can this agency be done? And all those things, those services can be rendered by you. Please go on the next slide. When I'm talking about project control, what are the considerations? We have to plan, we have to have the permitting and easements. That is basically permitting a pipeline to be installed. There are locations which have to be taken possession of. The easement has to be done. So those are there. When I'm talking about project control, I also need to identify the risk. I have to go for alignment design. I have to see to solve the pipe stress criteria. I have to have the directional accuracies and tolerances, the product pipe considerations. All those come under the project control consideration. Next one, please. Pratibha. When I'm talking about planning, what I mean to say is handling the overall project requirements, that is the product pipe diameter and materials, length and depth of the crossing or pipeline installation locations, work site and access conditions, feasibility of trenchless methods and equipment usage. If my equipment or the method itself is not feasible, there's no point, and all those things have to be understood and decided. Pre-planning and mapping means computerized alignment planning, and that is what you can go in if you have access to the see-through technologies. Please go ahead. Next slide, please. Now, what are the directions for project planning and execution? First of all, the basic Trenchle project considerations have to be understood, as I indicated in the beginning. Pipe path alignment considerations have to be understood. Directional accuracy and tolerances are essential to be understood and applied. Stress consideration and as-built drawing considerations have to be there. Please go on the next slide. Now, there are key performance standards for trenchless equipment operations, safety during the work, working drawings, sketches, compliant execution, appropriate use of equipment and tooling, machine operating procedures and sequencing, meeting the minimum qualifying competency standards of the operators. I'll just highlight one small situation. Say you are drilling in the ground, and unfortunately, your drill head goes and cuts the electric cable of 220 kV or any kind of power conductor which is charged. You know what would happen? Your machine will be charged, and the machine will be charged means it will have extensive electric charge in the whole system. Your drill rod will be charged, your machine will be charged, and God forbid, if your operator decides to jump and walk, he will be dead within seconds because that power will go out. There are basically methods by which you exit these machines. I mean, this situation. So all those things have to be understood or created. Yes, everything will not come and they're zero in your system, but my idea or my pressure is or my thinking is that please start thinking in these lines. Let's start advisory assistance systems for the ULBs, and slowly all these things can be cultivated. Please go on the next slide, Pratibha. I'm talking about the job site safety. There I'm talking about the operator skill, safety, health and environment issues, job site inspection and briefing, overhead structures, underground structures and appurtenances, trenchless, allied equipment safety, and electrical strike safety. All those things need to be understood and applied. And everything you can start from creating a small safety manual for your projects. From there to you can go for a design thing. Depending on what kind of capabilities you have and what kind of capabilities you can create with less effort. All those things can be done. Pratibha, go on the next slide. Pratibha. So this concludes the 4 sections. Now comes my proposition to all the faculty members or academicians which are listening to me. Please go on the next slide, Pratibha. Let's look at the requirements. As I indicated, we have been constructing maybe 1 lakh crore rupees every year. So there is a huge amount of infrastructure being built, and there are specific needs, current as well as future. Now, what are the situations we are facing? If you are aware, urban flooding is happening right, left, and center. Everywhere people are claiming that this year the monsoon was very huge. Sorry, your drainage system was not able to transport that percolation. So that urban flooding happened, and this gradually increasing because the floodplains and everything are getting clogged. The pipelines are not functional or not delivering. So that is one of the major need today. Believe you me, your boys and girls will find instant employment in all these. Operation and maintenance of existing infrastructure assets, smart city, utility operation and management, city gas distribution networks, enhance subsurface utility networks to cater the rising urban demands, major transportation and material transfer tunnels. On international demand side, better infrastructure for cities. There are so many cities where internationally where these projects are occurring or being conducted, and our boys and girls are getting employed there. Believe you me, the kind of engagement what they have is quite encouraging. So it is basically improvement and extension in more developed countries, and basic systems still needed in less developed countries. The boys and girls going to Middle East have pretty better opportunity for employment because they are working for tunnels and major infrastructure. Then even Africa, Far East, all these places which are not that developed, there also the infrastructure is being constructed because the pressure is still there. And everywhere we have the possibilities of these employments, assignments, design things, everything put together. Please go on the next slide. Now, what is the impact coming on the engineering professions? Increased market for underground construction. The time when I graduated, there was a desire of many of the students that let's join the structural design. I'll become a structural designer. Now, that particular profession has its application requirements, but trenchless technology, or rather subsurface construction, is becoming more lucrative. So it's increased market for underground construction, increased imperative for professionals to be more involved in underground space use issues, new geo-related research and technology development opportunities. There are instances where the political parties have been promising to create infrastructure using trenchless technology. And believe you me, because of those, they win the elections as well. And who will create those infrastructure? If not you and your students. Let's do that. Pratibha, go on the next slide. The way forward is subsurface construction requires adequate application of engineering inputs. Each subsurface project is different and needs to be planned, designed, and executed to suit the site requirements. Some of the important engineering inputs include specifications, contractual conditions, schedule of rates, standard operating procedures, method statements, subsurface utility engineering code, project supervision, code of practice for the drilling, operator competency standards. Now, INDSTT has published these books and manuals and also several reference manuals. In addition to these, there are about some 38 or 42 different publications which are being used extensively. Please go on the next slide. For proper project execution, INDSTT publications can be referred from our website, which is INDSTT at publication.html. There are several INDSTT training programs to overcome different challenges and cultivate operator and engineer skills. Practicing engineering professionals can enhance their skills and that way enhance their prospects. Students and entry-level engineers could benefit immensely by learning the technology nuances. Utility system owners can get help greatly in adoption of these technologies by developing their own capabilities with the help of INDSTT and obviously with the help of the institutions from where these things can be done. Please go on the next slide. Pratibha. To initiate the actions at the grassroots, we need to develop systems for creating professionals having sufficient understanding of trenchless systems. Engineering institutions need to become a part of this capacity creation process. That could be done through interacting with the local civic agencies or ULBs, that is urban local bodies, and providing them advisory assistance. Believe you me, it will also render revenues for the institution and for the expert who will be rendering those services. Students could be developed on the projects for the onward development of capabilities in them. For addressing technical capability gap, such institutions could work with us by establishing chapters at institution level. Pratibha, please go on the next slide. What I give to you or what I bring to the table, our publication, other trenchless publications published world over, INDSTT inputs. There are member network which I'm sure would be somewhere available in your city, wherever you are living, there would be some member there. So that member network, then there are training programs, other trenchless training programs other than us. Then comes Nordic India shows, which are major shows where you have exhibitions of equipment and then international suppliers and trenchless technologies come and talk about the new developments, what they have achieved and how things are getting better. Then creating INDSTT chapters in different institutions. Please go on the next slide. So this concludes the major part of the presentation. Please go on the next slide. The concluding remarks, what I have is Trenchless technologies offer an effective tool for subsurface construction activities. Due to aging infrastructure and explosive demands, nation will need to develop and enhance its trenchless capacities. Trenchless capacity enhancement needs to address each type of stakeholders involved in the project delivery chain. May that be the project owner, may that be the contractor, may that be the manufacturer, may that be the consumable manufacturer, may that be the pipe manufacturer, may that be, you think of it and it is there. And all of these locations will be served by your students one day or other. Engineering professionals are needed to be cultivated to serve this essential national need. Academic interventions coupled with industrial inputs are essence of this objective. Please go on the next slide. Remember, nation needs to develop its internal capacity for successful subsurface construction projects and vision documents where you can create all those things for the urban local bodies in your area, play a vital role. INDSCT provides a major platform for such activities and provides necessary knowledge for the developing this vision. Underground is the future. Let's maximize its potentials for our future generations. And this brings us to the end of my presentation. Please go on the next slide, Pratibha. For more details, you can contact us or visit our website. These are the contact details. On the next slide, Pratibha. And that is, thank you very much for your patient listening or hearing to me. Now, I would love to have open house discussion with the participants of this particular class. So stop sharing and open the participant discussion or open house.
Thank you, sir. If anyone has any question, please come forward. Anyone?
Can you please share this PPT, sir?
The PPT is with you. It will come to you. Yeah, this I have already sent to Pratibha, and she'll be just sending it to you.
Okay.
Professor Islam, can you introduce yourself? You're from which college?
I am from BIT Mess, Ranchi.
Ranchi. Fantastic. So you have basically a hilly region where you would have much rather major application of trenchless in different projects.
Yes.
Do consider going into or looking into this kind of profession. Believe you me, your students will be well employable. Please discuss if anybody got any doubts, please discuss that, because that will help me to understand whether I was able to communicate what I wanted to say.
I think, sir, there is no question, sir. Uh, when we'll receive the queries or question in WhatsApp group, sir, we will forward to you, sir.
Sure.
Okay, sir. Thank you, sir, for your valuable time and knowledge. Could I close the session, sir?
Huh? Almost. So,
Yes, sir. Yes, sir. Sir, with due permission of you, sir, could I close the session, sir?
Yes, please.
Thank you, sir.